So there was a question about like how do you decide which test, and is there some sort of chart or something? And Jaron was great at responding that there are lots of online sites where they'll try and help you walk through it. But really it's best if you kind of know what kind of data you have. And so you have two types of data. You have categorical data, where it's not a number, right? It's these broad categories like gender and political connection, all those things that Katie was talking about. And then you have numerical measures, right? And numerical measures can be continuous, like tree height, where you have infinite values, like you can have 3.6555 infinity meters, right? So it's infinite values. These are things you measure. Or you can have discrete numerical data, which that means that it's things you count. So like the number of community gardens, it's either 1, 2, or however many, 28, but it's not going to be 28.5. It's a discrete number because it's a count. Same with number of fish, number of people. These are discrete numerical values. You have, in terms of categories, nominal, which is names, right? This is the way to just remember that. You can't really put them in any order. Genotype example, you might put them in this order, but there's no reason necessarily to put, AA capitalized above the others, right? Whereas ordinal variables, which is what Jill got into with the Likert scales, we're all saying Likert now, as weird as it is, they can be ranked, right? So you might have, like the example I gave of low, medium, and high income countries, those you might consider ordinal. So if you know what type of data you have, you're going to be good to go in terms of figuring out what kind of stats you can run. So, so this is a chart. I shared it last time as well, but you guys can go back to this if you want it. These are not all the statistical tests that exist in the world, right? These are just some of the most common stats that we think you might use and might just get you, your feet wet. And also, once you know how to look, like sometimes you just don't know what you don't know. You don't know where to look to figure things out. My hope is that, through this, you kind of know, all right, if I'm starting with two groups, I'm probably in this t-test realm. And I might then have to figure out one tail versus two, paired versus unpaired. I may end up in Mann-Whitney land because it's not normal, okay? But hopefully if you're dealing with two groups and a numerical, something you're measuring in numbers, right? Between those two groups, you're in a t-test. If you have three or more groups, very similar. ANOVA is essentially a t-test for three groups. It is very similar in the way it's set up, okay? Now I started to allude to this point. If you have three groups and it says there's a significant difference between those three groups, you don't know, is it that A was bigger than B or is it that A was bigger than C? So there is something called the Tukey's post hoc test. I just want you to be aware. There are extensions on these tests that will tell you where exactly is that difference. Is it between A and B? Is it between A and C? So there are things we didn't get into tonight due to time. Same with Kruskal-Wallis. You could go into a Dunn's test, it's called. These wonderful, fantastic mathematicians that get their names forever engraved on these tests. Jill got into correlations, right, and regression. And we talked about how Spearman's, we didn't really show you that, but Spearman's is something to be aware of. Just all very similar ideas. How closely do two things relate to each other when you have two numerical variables, okay?